I'm starting to think about design for manufacture and what components I might actually choose. And the first thing I'm looking at are these 16-way switches. This is a Lorlin switch, got it from Farnell, and it's a binary coded decimal switch, which is really nice. You've got 16 positions and it gives you a 4-bit binary output, 1 bit pulled high, and so that works really nicely with a microprocessor. But these are expensive. In low quantities they're about £10 each, and they're also huge. That if I compare it to something like, here I've got a Thonkicon connector, which is a kind of standard Euro rack connector. If you can see that, the this sits way above this, so physically mounting both of these on some sort of user interface PCB is going to be really difficult. If I compare it, this is a sub-miniature single pole dual throw switch, which I might end up using. Again, it's way smaller physically than the Lorlin switch, so I don't think this is going to work. Looking around, there aren't many alternatives. You can get sub-miniature ones, such as these, and they're fine if all you want to do is control them, occasionally using for example, a small screwdriver just to set an input, but not for something that's going to be part of a user interface. So I've been looking around for an alternative and come across these, and you can buy these in a variety of different formats, but this one is a single pole 8-way switch, but you can buy them as single pole 3-way, 4-way, 6-way, or 2-pole 4-way, something like that, but they all have the same sort of footprint, and they're really cost effective. These are about £1 each. They're a nice size if you compare it to this sub-miniature switch. It's about the same vertical height, the body of it, so it would mount nicely on a circuit board. And what it gives us, though, is the problem of how do we then interpret the 8 positions using a microcontroller, and so we need some way of encoding that into a binary coded decimal. 8 positions would be 3 digits, 3 binary digits, so we need what's called an 8 to 3 line priority encoder. And in the good old days we used to use these, which is a 74LS148, and it's TTL logic, and TTL logic is 5-volt logic, so it's not ideal. The Raspberry Pi Pico runs on 3.3 volt GPIO pins, so we'd need to drop the voltages, buffer the voltages in some way. So instead I've been looking at these, which are the MC14532, and again it's an 8 to 3 line priority encoder, but it's CMOS, and so it will run off an input voltage anything from a volt or so up to about 18 volts, so it will run quite happily at the 3.3 volt level that we're running the right Raspberry Pi Pico. So I'm going to get some of these. The other problem I've got is that this Lorlin switch is a 16-way switch, and what I was going to do was somewhere in the middle I'd have divide or multiply by 1, and then I'd divide by 2, 3, 4, 5, etc. going in one direction, and then multiply by 2, 3, 4, 5 going in the other direction. So if I was to move to these switches, I've only got 8 ways, but I figured, well, why not just add a second little switch that is a divide or multiply switch, so I can choose from 1, 2, 3, 4, 8, 16, whatever my multiplier or divider is, and then I've just got another little switch where you can say, okay, I'm multiplying or I'm dividing. If this is set to 1, then obviously that makes no difference, and if it's set to something else, 2, we can multiply by 2 or divide by 2, and I think that would be actually quite neat. Also, with my design for manufacture hat on, I'm looking at what I'm going to need on the front panel by way of user interface components and what they actually are likely to be physically. So it's going to be a stereo delay, so it's going to have left and right in, left and right out, clock in, clock out, and these will all be on ThonkyCon sockets because they're fabulous. I'm going to need a dual potentiometer for some sort of input gain, and pots for wet and dry balance, feedback clock speed, some sort of clock indicator, a nice flashing LED, my rotary encoder for setting the delay length, and that's got the push panic switch in it, and then a couple of sub-miniature switches for clock multiplication and division, but also something to select as to whether the delay length is synchronized to internal or external clock or just free running, and then rotary switches for the clock divisor ratio, and something to select what the delay algorithm is. Fabulous post on Reddit from 4 years ago by As a Chemical Engineer, where he's gone through everything on modular grid and listed it by horizontal pitch size and looked at the frequency. And if we look at these, 8 HP is the most common width, followed equally by 4 and 6, and then 12, 10, and so on. And it's interesting to note that odd pitched modules are very infrequent, so there's hardly any 9 HP width, 11, 13, and so on. So I'm going to look closely at 12 HP and see if I can fit everything on that. Here are those 16 UI elements, all the pots, switches, ThonkyCon connectors, assorted knobs, rotary encoder knobs, that kind of thing. And this is a 12U Eurorack, blank Eurorack panel. So the game now is to try and work out how I can fit all of this lot onto here and whether it will go. And that's going to be interesting. And I think it's probably about time I started talking about KiCad.